Part 2 of talking about homework 8. So if you haven't looked at the first video, you need to go do that. We have 3 more programs to kind of look at what they're doing. There's a program, Python list sort. Okay, so what actually happens here, we have a value of n that we can change. So 10, 1,000, a million. And we have the numbers from 0 up to n minus 1 that are in a random order. And then we call numbers.sort. So this is using Python's sort algorithm to sort the numbers. In selection sort, we were doing the selection sort algorithm ourselves, going through and putting things in order. Whereas here, it's whatever Python's sorting function does, which I'm claiming has a running time that is something like this. And it is doing, depending on the size of n, it's doing quick sort. Okay, so you can run this and you get a running time there, 0.025, and you have a formula here that we can use for filling in this stuff right here. Okay, so we can run it with the time. That's easy. That's kind of probably the most interesting thing about this assignment, is running with different values of n and seeing what the time is. But then we want to see whether that kind of corresponds to what the formula says. Okay, so there we can have a comparison between selection sort, and Python's list sort is quick sort. All right, the other one we want to look at is anagrams. So I'm just going to run this first. All right. So inside of the anagrams code, there's a string, and it's looking inside of a dictionary file, a file with 38,000 common English words. And are there any anagrams for field? So rearranging the letters so that you get a word, and that found one filed. And we could try that with other ones. So we could try ants, say. Can you think of any anagrams of ants? None. We could try just ant. There's one, it's tan. Okay, so this code again is having a step counter. So there's the way it keeps track of the step counter is a little bit different here. You just need to be able to run it, but you should try to understand what's happening as well. It starts with steps equals 0, then somewhere inside it adds 1 each time something happens. And the claim on this one is that the running time formula should be n factorial. Okay, if I want to look at the running time for 5 on this one, then I need to put in on this program, our n is the length of the string. So this field, the way it started, that's a string that has 5 characters. If we wanted to have one that has 10 characters, field those or something. 10 characters long, something 10 characters long. Okay, so this may run for some amount of time. Some of these may not actually finish because the runtime gets to be too large. All right, and if the runtime gets to be too large, then eventually you kill it after waiting for a few minutes or a few hours or something like that. Let's see. If I run it with the time command, let's pretend that I waited a long time and then I Control C to kill it. And it tells me that it used 5.79. So I would put here greater than 5.79 seconds, because that's all I know. All right, so that may happen with any of these. Basically, if you're using the wrong algorithm, eventually it gets to be a problem. And this here would be a string of 100 characters. All right, and there's various ways you could get that typed in. You could just type 100 A's or something. All right, Anagrams B is a different algorithm, but it should give the same answer. Let's see. So that has field. And that gives the same answer of one anagram. And then you can run it with 10 letters and see what happens, measure the running time. Okay, that is, that's it. So we have two different algorithms for anagrams, two different algorithms for sorting, and two different algorithms for searching, and we can see the different behavior on all of them. And that's computer science. Good luck.